Hello everyone. Welcome to the demonstration of data structures laboratory. Today we people are going to demonstrate experiment 12. Aim of the experiment is given a file of n employee records with a set k of keys 4 digit which uniquely determines the records in file F. Assume that the file F is maintained in memory by a hash table of m memory locations with L as a set 2 digit of locations in HT. Let the keys in K and addresses in L are integers. So design and develop a program in C that uses hash functions H, where K points to L as H of K will be K mod M, and implement hashing technique to map a given key K to the address space L. Resolve the collision, if any, using linear probing. So in this particular problem, we people will be given a file of n employee records with set of k keys, and we people have to map those keys to a hash function and store them accordingly. If any collision occurs, then using linear probing, we have to remove the or the resolve the collision. So before proceeding to the implementation, let us first understand what hashing is. The hashing is the process of mapping large amount of data into a smaller table using hash function, hash value, and hash table. So the process of mapping the large amount of data into a smaller table using the hash function, hash value, and a hash table is called as hashing. Basically, there are two types of hashing. One is static hashing and second one is dynamic hashing. Static hashing means the process of mapping the large amount of data is done during the compile time. In the dynamic hashing, the process of mapping the large amount of data is done during the runtime. Hash function. A function can be used to provide a mapping between large original data and the smaller table by transforming a key information into an index to the table. The index value returned by this function is called as hash value, and a function that informs a data into a hash value to a table is called hash function. Okay, so what is a function here? What is a hash function? A function that can provide a mapping between the original data and a table is called as a hash function, and with the help of a hash function a particular value can be inserted into a table. So the hash function will return an index value. Using this index value, a particular data can be stored into the hash table, and this index value which is returned by a hash function, it is called as hash value, and the function that performs this functionality, it is called as a hash function. Then coming down next is a hash table. The data can be stored in a form of a table using arrays with the help of hash function, which gives a hash value as an index to access any element in the table. So the table in which insertion, deletion, and a retrieve operation takes place with the help of a hash value is called as a hash table. So in order to construct a hash table, the first thing is that we require a hash function. A hash function will generate a hash value. Using that hash value, the elements will be that occurs during the hash is the overflow. Now, with the size of the hash table is fixed, and the table is filled, then the total number of keys generated, then two or more keys will have the same hash address. Whenever the size of the hash table is fixed and the size of the table is smaller, the number of keys generated are more. In that situation, what happens? All of the keys will have the same hash address. This belongs to the two or more keys has the same option is called collision. The various techniques using which the collision can be avoided are open. Now, for this people are going to solve the collision using openness or linear code. In open hashing, the amount of space available for storing is in comparison by declaring a fixed array of hash table. So all the keys can store in this hash table without the user will. In the table, collision can be avoided by using another number block in the array. The collision can be avoided using linear probing. So what happens is that in the open addressing is that the amount of space available for storing the data is fixed at the compile time, and a fixed array of hash table is been created and all the keys are stored in this array itself, and we are not going to use the linked list. So once the hash values are being generated in the array, we keep on checking whether the data is filled or not. If the data is not filled, then on an unoccupied location the data is stored in the array. So this mechanism of storing the data in a hash table is called as linear probing. So to proceed with linear probing, the first thing is that we need to create a hash table. So to create a hash table, the first thing is that we require a hash table. Then to create a hash table, we require a hash function. Once a hash function is designed, from the hash function, we will get the index for each location in the hash table. Now, how to initialize the hash table? So to create a initial hash table, we will define a function called as initialize hash table. So here, based upon the size of the table, here the hash table will be initialized. Now suppose that there are 5 locations in the table. Suppose that the size of the hash table is 5. Then how to initialize the hash table? Now suppose this is the hash table. It is size is 5, so we want to initialize the hash table. So we will take a for loop here, and the name of this array is a, because in the linear probing we are maintaining an array, and with the help of an array we are going to initialize the with the help of an array we are going to represent a hash table. So first thing is that we will use a for loop and I value will be 0. So for I is equal to 0 till I less than hash size, here until unless this condition is true, we will initialize the hash table. So when I value is equals to 0, we will make a of I is 0. So a of I will be made as 0. The next I value will be incremented because it is a for loop. Then I is less than hash size. So when I value will become 1, I is less than hash size means we have taken hash size as 5. This condition is true. So a of 1 also will be initialized to 0. Then I value will become 2. 2 is less than 5. This condition is true. So a of 2 will also be initialized to 0. Then I value will become 3. So 3 is less than 5. It is true. So this for a of 3, 0 will be initialized. Similarly, at a of 4 also 0 will be initialized. So initial, the based upon the size of the hash table, all the locations are made 0. Then the next thing is that we have to identify the hash function. In the problem definition itself, we have been instructed to use a hash function based upon the modulus operator. So the hash function we people will be using will be h of k is equal to k mod m, as been instructed in the problem definition. So here m becomes the hash size. So this hash function we can implement in this way: int h int k, where k is the key that is to be generated. So here this hash function, the name of this function is h. It will return k mod hash size. What is the hash size? This is the size of the hash table. So instead of taking m here, we have taken as hash size. So this is how the hash function can be defined. Now the next thing is we want to find the index for the hash table for the given hash value. So for that, what we will do is the next thing is that in order to find the index for the hash table using the given hash value, so first how it can be done. So based upon this for loop, we can try to find out the index for a given hash table. Say for I is equal to 0, I is less than hash size, we will print I. So the hash table contents are 0, 0, 0. Size of the hash table is 5. So at each location what is the index. So this 0 is stored at index 0, this is 0 is at index 1, this 0 is at index 2, and so on. The fourth element is at index 3 and the fifth element is at index 4. So these indices we want to display. So with the help of this for loop we can print the indices. So the output will be of this form. So the same statement, instead of displaying as I here, we can display it as I mod hash size. So even the output will not be different, it will be the same. So using this statement also, the index value of the hash table can be displayed. So there is another way of displaying the indices of the hash table based upon a particular position. Now suppose that we are at position 0 and we want to display the hash size. So the hash index value can be displayed as position plus I mod hash size. If position is 0, so here it will be I value will be 0 means 0 plus 0 mod hash size. So the first index will be 0, then I value will become 1. So uh, position is 0 itself, 0 plus 1 is 1, 1 mod hash size we will get 1 here. Then I value becomes 2, position is still 0 because we are finding the index for position 0. So 0 plus 2, 2 mod hash size we will get 2, then I value will become 3. So 0 plus 3 mod hash size we will get 3. Then position is 0, I value is 4, 0 plus 4 mod hash size we will get it as 4. The next proceeding further, if we want the index value for when position is 1, so here instead of 0 now the position will become 1. Again the for loop will repeat from I is equal to 0. So here it will be 1 plus I value is 0. So 1 plus 0 it is 1 mod hash size, we will get 1 here. Then I value will become 1, 1 plus 1 mod hash size, that is 2 mod hash size, we will get 2 here. Then 3 mod hash size, we will get 3, then 4, and then we will get the hash value as 0. Similarly, by iterating the for loop in the same manner, we can display the index values when position is 2, position is 3, and when position is 4. Now moving further, we will try to write a function to insert an item into the hash table using linear probing. Now assume that these are the elements that we want to insert into the hash table. Initially we haven't inserted anything here. Okay. So the first element to be inserted is 11 here, then 12, then 13 and so on. So the function that will be defined is int I. Then we are taking the variable I, index and h value. These are of type integer. So h value is equal to h of item. So you remember h is a hash function. So it will return the hash value. Okay, so h value is equal to h of item. So item is 11, so we will pass h of 11 here. For 11 a hash value will be generated. So how will the hash value be generated? It will be 11 mod 5 because you can see the h of function. So this h function it will return what? K mod hash size. So our k value will be 11, hash size is 5, 11 mod 5 it will give us 1. Then this 11 you are getting the hash value as 1. So you have to place it at a position 11. So for to place it at a particular index, so this for loop is being used. So I value is 0. Then you check whether I is less than hash size. It is true. Then you will obtain index is equals to h value plus I. H value is 1. We have obtained here 1 plus I. 1 plus 0 mod 5 we will get 1. Then you will check if in a of index is 0. So what is your a of index? Index we have obtained as 1. Now we have to check a of 1 is equal to 0. It is true because your a of 1 initially all these contents were 0. Because at the beginning of the program itself we have initialized it to 0. It becomes true. So as it is true we have to break. Break means we have to come out of the for loop. Then what we have to do? At a of index we have to insert the item because a of index is 0. So at a of 1, 11 will be stored. Then next item to be inserted is 12. So here what happens is it will become 12 mod 5. So 12 mod 5 we will get 2. Then again this for loop will repeat. We have I is equal to 0. So it will be h value plus 0. So this will be 2 plus 0 mod 5. We will get this as 2. Then you have to check index is 2. A of 2 is equal to 0. So a of 2 is equal to 0. It is true. Then we have to do A of 2, we have to insert item 12. So at A of 2, 12 will be inserted. In the same way, now we'll try to insert element 13. So this function will be called h of value, h value is equals to h of item. Then here the item to be inserted is 13. So when the h value function is called, it will return me the hash value. So 13 mod 5, I will get 3. So again this for loop will execute. I value will be 0, I is less than 5. So h value we have obtained as 3. 3 plus 0 mod 5, we will get 3. Then you have to check whether a of 3 is 0. It is true. Then s in a of 3, in a of 3, we have to insert 13. In this way, we can insert 13. In the same way, 14 will be inserted into the hash table, and in the same way, proceeding further, element 15 will be inserted in the hash table at position or at index 0. So this is how the elements in the hash table can be inserted. In the same way, using the search hash table function, we can search for the elements in the hash table. Now suppose that the key to be searched is 12, then so we have to search for it. So here it will be h value is equals to h of key. So 12 is to be inserted. 12 mod 5 will give me the hash value. You will get it as 2. So here there is a for loop. It is same as that of insert. So using this for loop, we will obtain the index. Index will be h value is 2. So 2 plus 0 mod 5, we will get 2 here. Then we have to check if key is equal to a of index. So key is what? 12. A of index, that is a of 2. So a of 2 is also 12. Key is also 12. This is true. So this function will return 1. If the element is not found, then a of index will be 0. Then the function will return 0. Okay. So in this way, this particular program can be implemented. So we want a menu driven program to be created. Then if the user wants to insert, search and display and exit, then appropriate choices can be given. And then based upon the choices, the appropriate case will be executed. Case 1 is for insert, case 2 is for search, and case 3 is for display. So as many number of times the user wants to insert the element, for those many number of times the elements will be inserted. Okay. Now coming down to an example to construct a hash table of size 15. We have been given these following words and we want to insert it into the hash table using linear probing. So first thing is that for these alphabets, we have to obtain the hash value. So we all know that these are the words in English. In English, there are 26 alphabets from A to Z. So each alphabet we will number as A as 1, B as 2, C as 3 and so on, Z as 26. So we assume that A is at position 1, B is at position 2, C is at position 3 and so on, Z is at position 26. So in this way we will number from A to Z. Then based upon the position of each element, we will obtain the sum of the position. Then we will take the mod with the hash size. Then we will obtain the hash address. For example, the first word to be inserted in the hash table is like. So L is at position 12, I is at position 9, K is at position 11 and E is at position 5. We will add all these positions. We will get 37. So hash size is 15 because we want to construct a hash table of size 15. So 37 mod 15, we will get it as 7. Then in the same way, A is at position 1, 1 mod 15, we will get 1. Then for tree, the sum of the elements at various positions, we will get it as 48 because T is at position 20, R is at position 18, E is at position 5. We add it together, we get 48. 48 mod 15, we will get 3. In the similar way, we will obtain the hash addresses for all the 14 words that are being given. Now one by one, we will try to insert these values into the hash table, which is of size 15. So here what happens is, we are having the hash table. So like will be stored at position 7. So like is stored at position 7, A at position 1 and tree at position 3. A at position 1 and tree at position 3. Above there is next is U. U should be placed at position 1, but 1 is already occupied by A. So U cannot be placed at 1. So we have to find the next empty location. So the next empty location is 2. So here U will be inserted. Then the next element whose hash value we have obtained is first. So for the first, the hash value is 12. We will check whether the location is empty. So this location is empty. So first will be inserted at position 12. The next word to insert is find. Its hash value is 3. 3 is already occupied. Here 3 is already stored. So we will find the next empty location. So after 3, the location 4 is free. So find will be inserted there. The next word is A, we have to insert. A is already at position 1. Duplicate A will not be inserted again. So A will be skipped because A has occurred twice in the list. A here and A here. So only once it will be inserted into the hash table. Then moving further, the next word we want to insert is 2. Its hash value is 5. Check whether 5 is empty. Yes, the location 5 is empty. So 2 will be inserted. Then moving further, grow is the next word. Its hash value is 3. So 3 is already occupied with word tree. So grow cannot be inserted at position 3. So find the next empty location. So the next empty location is a 6. So here grow will be inserted. Then moving further in this way, and is the next word to be inserted whose hash value is 4. So location 4 is already occupied. So and cannot be inserted at 4. So and will be inserted at 9. The next element to be inserted is then. Then we have to insert it at position 2. So we check position 2 is already occupied. So then will be inserted at location 10 because 10 is free, 2 is not empty. Then branch is to be inserted at hash value 1. 1 is already occupied. Then we have to move forward and see that 11 position is free. So branch will be inserted at 11. Then the next word we have to insert is out. Out has a hash value 11. Check whether the location 11 is free. It is already filled with branch. So move out further and see whether ahead we have any empty location. We have a location 13 already available. So we will insert out here. So in this way, in a hash table using linear probing, the elements can be inserted. Okay. Now the next thing is that we will try to execute the program. So we'll move down to Turbo C. I have already typed the program and I have debugged the errors. So once again we'll compile the program. The program is error free. Then we will execute the program. Now I have, see, this is to create a hash table of employees. So I will give the number of employee records as 5. So I have to give 2-digit memory locations that for the hash table. So I will give it as 10, 2-digit memory locations. So what the program will do is it will create 10 memory location, table of 0, table of 1, table of 2, table of 3 and so on. Randomly 5 memory hash values will be created and the employee records will be inserted. So employee 0 will be hashed at 346, employee 1 at 130, employee 2 as 10982, employee 3 at 1090, employee 4 as 11656. So these hash values will be generated, and at these hash values in the table, these employee 0, 1, 2, 3, 4, these data will be hashed. So this is how this particular program can be implemented and it can be executed. So today we have demonstrated the 11th 12th experiment, which basically deals with creating the hash records for employees, and here n number of employee records can be stored into the hash table. With this we will end the session. Thank you.